Imagine a world where computers are living, breathing entities. Picture a future where silicon chips give way to biological processors. This is the incredible future of biocomputing. We are on the cusp of a technological revolution. For decades, silicon has reigned supreme, but even silicon has its limits. We can no longer cram more transistors onto a chip. The future lies in harnessing the power of biology. Human cells are miniature marvels of nature. They can process information and repair themselves. Scientists are transforming these cells into the processors of tomorrow. This is the dawn of living machines. The story of computing has been one of relentless miniaturization. We've squeezed billions of transistors onto silicon wafers, each generation of chips smaller and more powerful than the last. But this incredible shrinking act is reaching its physical limits. We are approaching the atomic scale, where the laws of physics start to behave in strange and unpredictable ways. Silicon, for all its versatility, is reaching its computational ceiling. Heat dissipation becomes a major obstacle as transistors shrink, and quantum effects begin to interfere with their operation. The future demands a radical new approach, a departure from the limitations of silicon-based technology. Nature, as it turns out, has already provided us with an answer: the living cell. Our bodies are testament to the incredible computational power of biology. Every cell is a miniaturized marvel, capable of processing information, storing data, and carrying out complex tasks with remarkable efficiency. Unlike silicon, which relies on electrical signals, cells communicate and process information using a complex language of molecules. This allows for immense parallelism and energy efficiency, far exceeding anything we can achieve with even the most advanced silicon chips. To understand the potential of biocomputers, we need to reimagine the very concept of a computer. Instead of silicon chips etched with transistors, imagine a network of living cells, interconnected and communicating like a vast biological circuit board. Scientists are already making remarkable strides in this direction. They are engineering cells to perform specific computational tasks, essentially turning them into living transistors and logic gates. These biotransistors can be assembled into circuits, much like their silicon counterparts, but with the added advantage of being self-assembling and self-repairing. One promising approach involves using DNA, the molecule of life, as a programmable building block. DNA's ability to store and transmit genetic information makes it an ideal candidate for creating biocircuits. Researchers are developing techniques to program DNA strands, creating intricate structures capable of performing logical operations. Another exciting avenue of research focuses on harnessing the power of neurons, the specialized cells that form the basis of our nervous system. Neurons are masters of communication, transmitting electrical and chemical signals with incredible speed and precision. In a groundbreaking experiment, scientists taught neurons to play Pong. They connected neurons in a petri dish to a computer running the game. The neurons quickly learned to control the paddle and return the ball. This experiment shows the potential of biocomputing. Imagine scaling this to millions of neurons in complex networks. Neurocomputers could surpass silicon-based systems, revolutionizing AI, drug discovery, and personalized medicine. They could even enable brain-computer interfaces, merging human minds with AI. The brain-computer interface, merging mind and machine. The most awe-inspiring application of biocomputing lies in brain-computer interfaces, or BCIs. Imagine a world where thoughts translate into actions, where the paralyzed can walk again, and the blind can see through artificial eyes. BCIs create a link between the brain and devices, allowing us to control machines with our minds. While still early, BCI technology is advancing rapidly, thanks to breakthroughs in biocomputing. Healing from within. Biocomputers in medicine. Biocomputers hold immense promise for revolutionizing medicine. Imagine a future where diseases are diagnosed and treated at the cellular level. Scientists are developing biocomputers that can detect specific molecules like cancer cells or viruses. These devices could provide real-time health monitoring and alert doctors to potential problems. Biocomputers could deliver targeted drug therapies, releasing medications only when needed. This would reduce side effects and increase treatment effectiveness, especially for cancer. Programming cells opens possibilities for regenerative medicine. Imagine using biocomputers to repair tissues, grow organs, or reverse aging. These applications are rapidly moving into the realm of possibility. The ethics of thinking cells. Navigating uncharted territory. The development of biocomputers raises profound ethical and philosophical questions that we, as a society, must carefully consider. As we blur the lines between living organisms and machines, we enter uncharted ethical territory. One of the most pressing concerns is the issue of control. If biocomputers become as intelligent or even more intelligent than humans, how do we ensure that they remain under our control? How do we prevent unintended consequences that could arise from their actions? Another ethical challenge relates to the use of human cells in biocomputing. Is it ethical to manipulate and engineer living cells for computational purposes? What are the rights of these thinking cells? Do they deserve the same ethical considerations as any other living organism? The potential for biocomputers to enhance human capabilities also raises concerns about equity and access. Will these technologies be available to all, or will they exacerbate existing social and economic disparities? These are just some of the ethical dilemmas we must grapple with as we enter the age of biocomputing. Control, consciousness, and the future of intelligence. The advent of biocomputers also forces us to confront fundamental questions about the nature of intelligence and consciousness. If we can create machines that think and learn like humans, does that mean they are conscious? Do they experience the world in the same way we do? These are questions that have puzzled philosophers and scientists for centuries, and there are no easy answers. However, the development of biocomputers brings a new urgency to these questions. As we create machines that increasingly resemble biological systems, we need to develop a better understanding of what it means to be intelligent and conscious. Some experts believe that consciousness is an emergent property of complex systems, whether biological or artificial. As biocomputers become more sophisticated, they argue, they may eventually develop consciousness as a natural consequence of their complexity. Others argue that consciousness is unique to biological systems and cannot be replicated in machines, no matter how complex they become. The debate over machine consciousness is likely to intensify as biocomputing technology advances. Biocomputers and the environment, a sustainable future? As we search for sustainable solutions to the world's growing environmental challenges, biocomputing offers a glimmer of hope. Unlike traditional silicon-based computers, which require vast amounts of energy and resources to manufacture and operate, biocomputers have the potential to be far more environmentally friendly. Living cells are inherently efficient and self-replicating. They can be grown using renewable resources and operate at much lower temperatures than silicon chips, significantly reducing energy consumption. Biocomputers could therefore play a key role in creating a more sustainable future. Imagine biocomputers used to monitor and regulate pollution levels in real time, optimize energy grids, or develop new bio-based materials that are both biodegradable and sustainable. The possibilities are endless. By harnessing the power of biology, we can create a new generation of computing technologies that are not only more powerful and efficient, but also more harmonious with the natural world. The biocomputer revolution, a new era of innovation. The development of biocomputers is not merely an incremental step in the evolution of technology. It represents a profound paradigm shift, a fundamental change in how we think about and interact with the world around us. Just as the invention of the transistor and the integrated circuit ushered in the digital age, so too will biocomputing usher in a new era of innovation, an era where the boundaries between biology, technology, and information blur, creating unprecedented possibilities. This revolution will touch every aspect of our lives, from healthcare and medicine to energy, manufacturing, and even art and entertainment. It will transform how we communicate, learn, work, and play. The biocomputer revolution is not something that will happen overnight. It will require years, even decades of research and development. But the journey has already begun, and the potential rewards are too great to ignore. A future shaped by biology, our responsibility, our choice. We stand at the threshold of a new era, an era where the power of life itself will be harnessed to create technologies beyond our wildest dreams. Biocomputing holds the key to solving some of humanity's most pressing challenges, from curing diseases to creating a more sustainable future. But this power comes with great responsibility. As we venture into this uncharted territory, we must proceed with caution and foresight, carefully considering the ethical implications of our creations. The future of biocomputing is not predetermined. It is a future that we will shape through our choices, our actions, and our values. It is a future where we must strive to balance the pursuit of innovation with the preservation of our humanity. The biocomputer revolution is upon us. Let us embrace its potential while remaining mindful of our responsibility to create a future that benefits all of humanity. Thank you for watching this episode of TechandTrek. If you enjoyed this video, please share it with your friends and subscribe to our channel for more exciting content on the future of technology.